This is problem 2 from homework 10. It asks us to think about how much coal an engine can lift out of a mine. Um, I know that as this engine is lifting coal out of the mine, it's lifting it at constant velocity. Um, I also know that I'm interested in how much coal per minute I can get. So power is work over time. So work is power times time. So I can calculate the total work my engine can do in 1 minute. So if I'm lifting this coal at constant velocity, I know that the work from the engine plus the work from gravity must be 0, since the net work is 0. We're not trying to fling the coal out of the mine, we're just trying to lift it at constant velocity. The work from the engine is power times time. The work done by gravity is the weight of the coal, so mg, times the height with a minus sign because gravity is doing negative work on something as I lift it. And so in this problem, I can just equate those two things. The work done by the engine plus the work done by gravity on the coal has got to be 0. So solving for m is power times time divided by g times h. So given the things that I have, this is 500 watts multiplied by 60 seconds divided by 10 meters per second squared times 50 meters. Conveniently enough, I can see a factor of 500 that I can cancel in both numerator and denominator. So I'm going to get 60 of something. Let's make sure that the units are right. Note that 1 watt is 1 kilogram meter squared per second cubed. You can convince yourself of that. So all of the meters squared per seconds cubed cancels the other things that I have. So watts cancels with meters per second squared, another seconds in the denominator, or excuse me, in the numerator, and then another mass in the denominator, and gives me a number of kilograms. So the mass is 60 kilograms. So that was a pretty simple problem. Here you don't know a velocity, so you don't use power equals force times velocity since you do not know a velocity. You could do this problem, you could ask like how, involved thinking of like mass that you were propelling at some speed, but that's much harder and you're just going to get a bunch of factors that cancel compared to this. You know time, so 500 watts times 1 minute is 30,000 joules. And the rest of the problem is based on that.